For years, the narrative was that Microsoft hated Linux. Now they ship their own distro, Azure Linux. The confusion is real. Is this just a corporate political pivot, or does it actually solve engineering problems generic kernels ignore? For AI practitioners deploying models on edge devices and cloud infrastructure, the answer lies in latency and hardware acceleration, not politics. This isn't about killing Ubuntu. It's about an OS foundation built specifically to stop GPU bottlenecks that standard distributions create during inference. To understand why this matters, we have to look past the headlines of corporate feuds. The shift from calling Linux a cancer to building our own distribution signals a deeper change in how software must behave when AI becomes the primary workload. For decades, operating systems were designed for general-purpose tasks, running office suites, browsing the web, and managing files. They prioritized broad compatibility above all else. But as artificial intelligence models have grown massive and hardware has become increasingly heterogeneous, that old model is breaking down. A systematic review of 108 studies confirms a critical shift in this landscape. The research indicates that when AI workloads scale up to modern sizes, traditional static kernels simply struggle with the dynamic resource allocation required for real-time performance. This creates an engineering gap where generic distributions fail. Academic consensus from institutions like Zhejiang University and the Chinese Academy of Engineering highlights that intelligent operating systems are now a requirement rather than a luxury. These new OS designs must optimize memory management and process scheduling at the kernel level to achieve low-latency inference. The problem is not just about having powerful GPUs or TPUs. It is about ensuring those expensive chips spend their time calculating model outputs instead of waiting for the operating system to shuffle data around inefficiently. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This brings us to the architecture of Azure Linux itself. It is crucial to understand that this distribution is not a forked copy of Ubuntu or Debian, which are built on the Debian package management system with apt repositories. Instead, Azure Linux is an RPM-based distribution derived from Fedora sources but heavily modified with Microsoft-specific innovations designed for cloud-native workloads. While generic kernels prioritize broad compatibility across every possible hardware configuration imaginable, this distro utilizes declarative TLML configuration and hardened security postures to minimize divergence while maximizing performance. The design philosophy here is distinct. It assumes a specific infrastructure stack where the operating system must actively manage heterogeneous resources rather than just passively running on top of them. The core value proposition lies in what researchers call AI-OS convergence. This involves integrating artificial intelligence directly into OS mechanisms, moving beyond simple software wrappers or conceptual templates that often lack active development. By embedding machine learning models into the kernel, the system can self-adapt scheduling and memory allocation based on real-time workload demands. In practical terms, this means the operating system learns which processes need priority access to GPU resources as they arise, reducing inference latency for edge computing tasks that generic systems cannot match. The research points out 5 distinct author affiliations behind these findings, underscoring a global academic consensus that optimization must occur at lower stack layers to handle hardware diversification efficiently. When we analyze the trade-offs of this approach compared to standard distributions, the differences become starkly clear for practitioners. Ubuntu and Fedora are excellent general-purpose choices, but they often introduce overhead when running specialized AI inference tasks because their scheduling algorithms were not designed with deep learning latency as a primary constraint. Azure Linux flips this script by treating resource allocation as an adaptive problem rather than a static configuration. The RPM-based foundation allows for tighter control over package dependencies and system libraries that are critical for high-performance computing environments. This reduces the generic kernel drag, where standard distributions might waste cycles on background processes or suboptimal memory paging during heavy model inference. The deployment reality reinforces why this is not just theoretical. While many experimental projects labeled as AI operating systems exist only as software wrappers with no active development, Azure Linux stands out as a production-ready foundation supporting virtual machines, containers, and bare metal platforms optimized for the Azure infrastructure stack. Developers are currently facing a noise trap regarding Microsoft's history with Linux, leading to hesitation in adopting new tools without clear technical justification. This distro offers a predictable lifecycle and native integration with cloud services like monitoring and identity management that generic kernels lack. The goal is to directly address the hardware acceleration bottleneck where standard distributions fail to optimize GPU utilization during inference. For an AI engineer choosing between operating systems, this distinction changes how you approach infrastructure decisions. It moves the conversation from package compatibility to throughput and latency guarantees. You are no longer just selecting a distribution, you are selecting an OS foundation that actively participates in optimizing your model's performance through kernel-level interventions. The integration of expert systems and machine learning into core functionalities like resource management, adaptive performance, and security allows for dynamic operational contexts where the system reacts faster than any human administrator could manually tune settings. The evidence is clear. As AI systems grow massive, optimization must occur at lower stack layers to handle hardware diversification efficiently. Azure Linux represents a practical application of this principle, distinguishing itself from generic Ubuntu or Debian forks by leveraging its RPM base and Microsoft-specific modifications for cloud-native workloads. This shift ensures that the operating system supports the unique demands of modern AI inference rather than acting as a bottleneck. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.